everyone. Welcome to the Instagram Live for the Biotechnology Advanced Program. My name is Amanda Rochon. I usually just go by Mandy. I coordinate and teach in the biotech program. So just to give you, because it's Halloween, a little bit of background, I think it was 2019, all of the instructors picked their favorite element from the periodic table, and we all dressed up as our elements for Halloween. I think it was the year before that, or 2 years before that, a bunch of students got together. They all dressed up as amino acids and walked together through the hallway as a chain. So we do have some fun Halloween costumes throughout the years. So if you're attending, I'm assuming you want kind of some sort of information, you have some interest in the biotech program, so hopefully I can give you some answers, and if I don't, there's definitely ways you can reach out to me and get some of those answers. So just to give you a bit of a breakdown for our program, so we usually just call it the BTF program for short. We have 5 semesters that make up our program, 2, 3, 4, and 5. Of those semesters, we spend 4 of them on campus, in class, variety of things, we'll touch on some of those, and semester 5 is your placement semester. So we do have a September intake and we have a January intake, so whichever one you do, you're going to have the same number of semesters, it's just how they occur is going to change a little bit. If you want more information on that or want to understand it better or come up with a plan for how that might work, you can email me. The email address is just BTF coordinator at flemingcollege.ca. And if you go to our program page on the website, you can also find that there. It's just on the right-hand side, as well as a lot of information about our program to kind of get you started, maybe finding some of those answers. But if anything isn't clear, you want more information, absolutely reach out to me. And if there's anything I can't answer, I'll try to direct you to the right person or department or website to get those details. So when we look at the semesters and what we're doing, the main focus of our program is getting you hands-on skills in the lab. So what can you do, what can you show? There's lectures and there's background content to give you all the theory and the understanding of those things, but the main focus that we're doing is here in the lab. So I have my little cheat sheet with the number of hours. The hours I'm talking about are the ones you're going to spend in the lab doing those hands-on skills. So semester 1, you have 98 hours. Semester 2 is 126 hours. Semester 3 is 154. Semester 4 is 126 hours. And your semester 5, which is your placement, is up to 600 hours. That is the main focus of our program, all these hands-on skills. Our goal is to give you a skill set, you develop mastery to different levels for some of those skills, and then you leave our program, you do your placement, you get some more mastery, real-world application, and then by the end, you are somebody who has this skill set and is also trainable. So we're not telling you, oh, this is how you do it, this is how it works. It's this is the skill set, you take it and go make it your own in the field, the career you see yourself doing. So we do have a couple of demonstrations. Right now we're in our bio lab, so it's a nice, bright, open space. We have those yellow chairs. Those chairs are actually new. They kind of give a nice, bright. Same chairs are on the other side, which is our chem lab. They're set up slightly differently, so it have different kind of functionalities, but we can make most of our classes run depending on what we need to do. So you'll spend a lot of time here, you'll spend a lot of time across the hall doing your hands-on activities. And depending what you're doing, you're going to need various safety equipment. So I got my lab coat on, everybody will need their lab coat. We got our gloves. We call these all the PPE, personal protective equipment. Gloves, I have glasses. So I have these big honkin' safety glasses that fit nicely over top and will get fogged up as I'm talking, so don't be surprised about that. So the first thing we can come over here and take a look at, this is our rig kind of set up for DNA. So this is an agarose gel. I'm taking it out so you can get a better view. So think about Jell-O. If you ever made Jell-O, you boil the water, add the Jell-O mixture, dissolve it, and then you let it solidify. Agarose, pretty much the exact same thing. So we usually put combs in, and those make the wells, so where you're going to load your sample into. So we're going to do a little bit of a demo with that. Something that you're going to get a lot of mastery and exposure to are these pipettes that we have here. So each one does a different volume, 1,000, 200, 20, 10 microliters, and this one can even go down as low as 0.5 microliters, like teeny tiny, barely a drop. So very accurate, precise instruments. And then we have pipette tips that go, depending on the size, each one. And then we have a very sophisticated waste container. I really like yogurt, so probably once a week I'll bring my empty yogurt container. So just as a demonstration, I'm going to leave my safety glasses off for this because they're getting fogged up. So I'm going to use my P20 pipette. I have it set to 15 here, so we're going to pipette 15 microliters. And this pipette actually matches with the yellow tip, so I need one of those. And one of your semester 1 courses, you spend kind of 2 lab periods learning about these, practicing using them, holding them. It's going to become kind of a secondary skill, just like you pick up a fork and you eat. Your pipetting is going to become that kind of muscle memory. You just do it, and you become a pro at it. Starting off, it's going to be hard, but you're going to get by the end of it, you're like, oh yeah, these things, it's fine. So don't worry about that. This dye that we have, all of our DNA samples are going to get mixed with some sort of loading dye. So this is an example of one of our loading dyes. It's called Orange G, or just OG. So you can see that it is orange in color. So I am going to suck up 15 microliters of that, have it in my pipette tip there. And we already have some samples loaded in the first row, so you will see those already. I use this hand to steady myself because you can see sometimes your hand gets really shaky, so this helps to steady me. And look over top and find my well, and very slowly add my sample till the end. And then it's resting, sitting in the well. So I'm going to do that again. I'm going to pick a different color. Depending on what you use, your dye color might actually be blue. So this is an example of the same thing. The dye in this case is bromophenol blue. So I'm going to get 15 microliters of that. And so the idea when you're doing work with DNA is that you would actually have your DNA sample mixed with a bit of the dye, and then you'd be loading it, as I'm doing, helping to steady myself, into the well. And other people in the class would be using the same gel as you, and everybody be loading their own samples in their own wells. And then once the whole thing was loaded, put the lid on, which connects the leads, and we connect that to a power supply, turn on the current, and the DNA will migrate through the gel. And then, as it is right now, we can't see the DNA in the gel. We have a gel dock, fancy setup, which has a UV light and a camera built in. Put it in, close the door, turn on the UV light, we take a picture, and we can see, and we use this to assess the quality of our DNA. So you've extracted DNA, how good is it? So that helps us answer that question. So that's one of the things that we do here, and you do it a lot. DNA courses, you also do it in molecular biology for a different application. So it's a skill set that you learn that can be used in many different areas. So we're going to go over here. I'm taking my gloves off. My personal preference is not to wear gloves when I'm working in front of a Bunsen burner. That's what we're going to be doing here. Put my safety glasses back on though. So I'm going to turn on my Bunsen burner. Give the gas a second. Alright, first try, got it lit. So what we're going to do in this example, we have a couple of transition metals, and we're going to actually do a flame test. So a flame test is a color change that you're going to observe, and that will allow you to identify the metal that is present. Transition metals especially have this property, so we have a nice little loop here. So this loop, we're actually going to dry it off a little bit. We're going to dip it in a solution, very dilute solution of hydrochloric acid, just to get it wet. We don't want to use water because the water, especially if it's tap water, is going to have its own elements in it, and those are going to confuse the results. So this is solid powder of strontium chloride. One of the skills you're going to learn here is being able to open and close something. Just one hand. Takes a lot of practice. Just take these off. So we're going to expose it to the flame. You see that beautiful red color that comes out, and that is the strontium. So this will help us identify a metal that is present, or various things where you want to identify. Doesn't necessarily mean you're going to use this technique, but it's understanding that you can do different things to identify the presence of metals and how those work. I'm going to clean that off. Safety glasses back on. And we're going to try one more here. So we have another powder. So in this case, you can see it's nice and pretty blue, and it is our copper sulfate. Yes. Put a bit of that on. Make sure this is on, and there's that beautiful green color, almost kind of a teal. I just like this one because the colors are so nice. But it's learning that metals and various things, you'll see this in microbiology, you do various different types of plates and testing and growth, color responses or certain types of growth, or it doesn't grow, and you can answer questions, especially when you're talking about water quality or various types of bacterial or virus testing. Those kinds of things you can answer with a lot of like positive or negative results in that case. So that's just kind of two spectrums of what we're talking about or what you'll experience in our program. There's various other things. Semester 1 and Semester 2 are kind of your general introduction into the program, get to know the basics of what we're doing. Semester 3, you get a lot more specialized. You learn molecular and micro, and you start to see where a lot of the skill set can be applied. And so we start to talk about placement in Semester 3. And so you start to put things together. You get professional practice course, helps you build your resume, practice interview skills, so you get all that kind of job ready stuff to set you up so that when if you do have to interview for your placement, you've had that experience and you know what to expect. And so the goal is by Semester 4, we're starting to set up those placements. And you might be thinking, okay, well, how do you set up those placements? Do you just say, okay, you're going here, you're going here? No. We have a lot of relationships and a lot of placements throughout Ontario especially, but we always encourage students to do the research. So let's say you're moving back home somewhere near Toronto because you can live with mom and dad for free. You're gonna look in Toronto. And let's say you're like, okay, I really like microbiology, like any research that involves microbiology. So I'm gonna say, okay, how far out can you go? Are you willing to commute an hour and back each day, or do you wanna stay closer? Do a search in that geographic area. Find labs or researchers or whatever, companies that do microbiology. Look into them a little bit, and then you send me or one of the other faculty that are working on placement a list. You're like, these are the places I'd like to do my placement. Maybe we already have a relationship, and that's easier to set up. Maybe we've never heard of them before, and that's great because those are the ones we like. It's like, okay, we're gonna call them up, we're gonna send them an email. It's like, hey, this is a biotech program, 5th semester is a placement, they're gonna work for you for 4 months, they're gonna get real hands-on experience. Do you wanna have this student? And we're hopeful in that case that they're like, yes, that would be great. And then you get your placement done, and hopefully at that end of the 4 months, you're like, okay, this is what I'd like to do for a career. Maybe you get offered a job after placement, that does happen. You network, some people like to do further schooling depending on, okay, I really like this, I wanna learn more about this, and that leads them to their career path. But either way, our goal in this program is to get you those skills, to get you that practice, to get you that understanding of what you can do with those skills and how they apply in various fields. And then you take that, make it your own, and apply that to placement and kind of figure out your career path using those skills. So hopefully that gives you kind of a background information that you need for the program. Always encourage you to go check out our website. It also breaks down the courses you're taking each semester. You can always email me, btfcoordinator@flemingcollege.ca. Answer questions for you. I can direct you to certain websites. Last night I was going back and forth with a student who had questions.